Hello, everyone, and welcome back to your channel of Math and Engineering Made Easy. We are in the process of solving quadratic equations. And yesterday we started with the factoring method. Today we are going to look at the second method that we discussed or that we mentioned, which is completing the squares. So the idea of completing the squares is that if you give me a square, like you say x squared, say equals 4, and you ask me to solve for x, I would take the square root of both sides, and I have to be very careful that when it's a square equation, it has to have two solutions. So don't say x equals 2 as some do. No, if it's x squared equals 4, you take the root of both sides and you get x equals plus or minus 2. Okay, so that's basically the idea. We are going to solve the equation and put it in a shape that looks like x squared equals a squared. Okay, so I will talk about that through examples that we will solve. Okay, so that's a worksheet that has 12 problems, so probably I'll do the even ones. And um, I will differentiate between the first six, seven problems and the last five. You see, if you concentrate on those, you will see that in the first seven problems, and we are going to do three of them, the coefficient of x squared is 1. And when it's 1, the problem is so easy. Doesn't mean that it's so hard when it's not. But when it's not 1, there would be two approaches. One approach that is usually used, which I don't like, and I will tell you why. And another one that maybe more a little more work, but it's simpler. Or you may disagree with me, that's fine. You can use either method. So I have a blank page here. Okay, so I will start with problem number two. And it tells me x squared minus 10x equals 22. By the way, you can, whether the constant is on the right or the left, it doesn't really matter. Okay, so I'm gonna leave it on the right. This one is on the left, so we will decide. I mean, it's up to you to move it in the get-go from the beginning or to move it later. It really doesn't matter. But when I look at the left-hand side, I see an x squared term, an x term, and there is no constant. But I know that if I'm going to square x plus or minus a number, I will get x squared plus or minus twice ax plus a squared. So I have x squared, I have negative 2ax, but I don't have a squared. So I need to add a squared to make it a perfect square. And you say, how do I find a square? Look at this equation. The middle term is basically twice ax. So if I look at the coefficient, which is twice a, and I divide it by 2, so divide the x coefficient by 2, I will get a. Then I square it, I will get a square. So I'm going to add a square to this side to make it a complete square. Say, wait a second. You can't change a problem by just simply adding a square. Oh, add it to both sides. And now I made my problem look like x squared equals 4 or x squared equals 2 squared. So x equals plus or minus 2. But instead of x, it's going to be x plus something, then or minus something. So I will either subtract or that or add that thing to find x. Let's take it one step at a time. So when I look here, I see x squared minus 10x. The negative 10 here is negative 2a. So if I divide it by 2, it would become negative a, which is negative 5. So eventually, I know that the left-hand side would be x minus 5 squared, right? I divide this by 2, it's -5, so I know it's going to be there. But how? Again, when I divide the -10 by 2, it's -5. Doesn't matter if it's positive or negative because we are going to square it. So it becomes 25. So I will get x squared minus 10x plus 25 equals 22 plus 25. I just added 25 to both sides, so my scale stays in equilibrium. This side becomes x minus 5 squared. The right-hand side becomes 47. That means that instead of having x squared equals 4, I have x minus 5. In other words, if I have, well, I don't want to make it hard on you. I can write this as square root of 47 quantity square, right? Now it looks like x squared equals b squared, for example. So it means that x, which is x minus 5, equals plus or minus the square root of 47. Which means if I add 5 to both sides, I get x equals 5 plus square root of 47 or 5 minus square root of 47. I have two solutions. Sometimes people, if I have time, I may try to check this answer. So I'm going to write 5 plus square root of 47 between parentheses. And then I'm going to say, okay, take this number, square it, minus 10 times this number. What do I get? I get 21.999, which is 22. That's an approximation. Then I can go back and change the plus into minus. I'm just checking if I did some math error, and it's possible. So this is the second solution. I'm going to square it and then subtract 10 times this number. I get 22. So I know that I did my problem correctly. Let's move to number 4. It's identical. Oh my God, it's the same problem with 21 instead of 22. I think we skip that and we do something else because it's the same problem. It's just this would be square root of 40. Oh, that would be, no, that would be negative. So when I add when I add 25, it would be, yeah, that would be an easy problem. That's basically x is 3 or 7. I know that from factoring, right? 3 times -3 times -7 is 21, and -3 plus -7 is -10. I think we'll take another one, which I also know its answer. It's x plus 5 times x plus 1. But let's see how we do it if I have the constant on the left-hand side. I have x squared plus 6x. And then I say, well, if I divide 6 by 2, it becomes 3 squared, it becomes 9. So I need to add 9. Whether I leave the 5 on the left-hand side or I move it to the right-hand side, it doesn't matter at all. I can say, you can move it at the end, right? Equals 0. Oh, I should have left this in the same color because it's in the same original problem. And then I say, okay, as I said, if I divide 6 by 2, it becomes 3. I square it, it becomes 9. So I need to add 9 here. And then I have to add 9 to the right-hand side, right? Notice when I divided this by 2, I got 3. So that basically is x plus 3 squared. whatever you get when you divide this by 2 becomes added or subtracted if that was negative to the x. And now I will have to subtract 5 from both sides, right? Minus 5 minus 5. So I get 9 minus 5 equals 4, which is 2 squared. So when I take the square root of both sides, I will get x plus 3 equals plus or minus 2. Subtracting 3 from both sides will give me x equals 2 minus 3, which is negative 1, or negative 2 minus 3, which is negative 5. Yeah, I knew just by looking that two numbers that multiply to 5 and add up to 6 are 5 and 1. So I will have x plus 5 times x plus 1 equals 0. If x plus 5 equals 0, then x is negative 5. And if x plus 1 equals 0, then x is negative 1. So I don't need to check that. I know it's correct. Let's move to number 6. In number 6, I have the x on the right-hand side and the 4 on the left-hand side. So I'm going to subtract 6x from both sides and then subtract 4 from both sides. So I get x squared minus 6x equals negative 4. Okay? So I want to make that a perfect square. So what do? I divide the negative 6 by 2. So I know that eventually the left-hand side would be x minus 3 squared. So I can write this right away. And then when I square the negative 3, I get positive 9. So I'm going to add 9 to both sides to get 5. So that equals 5. Or root 5, in fact, plus or minus square root of 5, quantity square, which means x minus 3 equals plus or minus square root of 5. I'm going to add 3. Why this thing doesn't write? So I get x equals 3 plus square root of 5 or 3 minus square root of 5. Again, I'm not sure, so let me check the left-hand side and the right-hand side. If x is 3 plus square root of 5, here is x. I'm going to square it and add 4 to it. That's the left-hand side. The right-hand side is 6 times that, which is the same number, so it's correct. If I go back and change that into 3 minus square root of 5, square it and add 4 to it, is it the same as multiplying it by 6? Yes, it is. So I checked my answer. That's the first half. The second half, I'm going to take problem number 2. Number 8. Why did I say number 2? What number 2? We don't have number 2. Okay. Number 8, it says 2x squared minus 5x minus 3 equals 0. Here, I have to be careful. Remember here I told you that the middle number is negative plus or minus 2a times x. But the next problems, the last 3 problems, are not x plus or minus a quantity squared. It's, for example, ax plus or minus b quantity squared, because the x coefficient is no longer 1, it's something else. Of course, the method you will learn is to divide the whole equation by 2. Let's do it first, and then I will tell you what else we could do. So I'm going to divide this by 2 and by 2. If I divide the 0 by 2, it stays the same, but the left-hand side becomes x squared minus 5 half x minus 3 halves, which I'm going to move to the right-hand side as positive 3 halves, meaning I'm going to add 3 halves to both sides. Now, my equation becomes my twice a is negative 5 halves. See, I take the coefficient and say this is negative 2a. So I divide it by 2, it becomes negative 5. So when I divide this by negative 2, it becomes negative 5 fourth, meaning this is x minus 5 over 4 quantity squared, right? 5 over 4 squared is 25 over 16. You see, that's the problem. It's not a problem, but that's what I don't like. Students, many students get confused, not confused, but it becomes harder for them to deal with fractions, and we are going to square, and then we got to add or subtract fractions with different denominators. So you have to take a common denominator. It's a lot of work, but let's do it first, and then I'm gonna explain what I meant there. I'm sorry, I shouldn't have started that before finishing this. But since I added 25 16 here, I added here also. So I have an equation. Now I will take a common denominator of 16, and I say 16 over 2 is 8 times 3 is 24 plus 25. So this becomes 49 over 16, which is 7 over 4 quantity squared. Okay? Usually they will give you, not necessarily, but many times they will give you perfect squares. So when you take the square root, it becomes easy for you to proceed. So I will have x minus 5 quarters equals plus or minus 7 quarters. So either x equals, so I'm going to add 5 fourths to both sides. And I get x equals 7 fourths plus 5 fourths, or x equals negative 7 fourths plus 5 fourths. Here I get x equals 12 over 4 or 3. Here I get x equals negative 2 over 4 or negative 1 half. And again, you can go back and check if 3 and negative 1 half would make that 0, and it will. Notice that if I don't have a 1 here, meaning if that's a constant and there's another constant and I square them, I will get a square x square plus or minus twice a bx plus b square. So now the middle number, the coefficient of it is no longer twice a. It is twice a times b. Okay. So I want a, or a square to be, of course, a perfect square. 2 is not a perfect square. So instead of dividing the equation by 2, I'm going to multiply the equation by 2 and get 4x squared minus 10x minus 6 equals 0. A squared. So now I know that 4x squared minus 10x can be made as a perfect square. Of course, before that, I'm going to add 6 to both sides. Just move it from the get-go to... So this guy is twice AB. Notice that A is 2x, right? It's 2x. minus something square. And I need to know what is this thing. The negative 10 is negative twice AB. So 2 times A times B. So what is B? If 10 is 2AB, meaning 5 is AB, and since A is 2, then this has to be 5 halves. So when I multiply them, I get 5, the 2 and the 2 cancel, and when I multiply it by 2, because it's twice, 2 times 5 over 2. One of the 2's cancel, and 2 times 5 is 10, plus 25 over 4 equals 6 plus 25 over 4. 6 is 24 over 4. So when I add them again, I will get 49 over 4. Or 7 over 2 squared. So when I take the square root, the left-hand side is 2x minus 5 halves. The right-hand side is plus or minus 7 halves. So I'm going to add 5 halves to both sides. And I get twice x equals 5 halves plus or minus 7 halves. 2x is 12 halves, or 2x is negative 2 halves. 2x is 6, or 2x is negative 1. So x is 3, or x is negative 1 half. If you are comfortable working with fractions, then you use the first method. If you prefer to work with, at least in the beginning, to work with integers, then make this coefficient, make this coefficient a perfect square. Let's take problem number 10 and see if that would be, which method would be easier. So let's look at number 10. Number 10 says 6z squared minus z equals 15. 6 is not a perfect square. 6 is 3 times 2, so I don't even have anything. I have to multiply the whole equation by 6 if I want to use the second method, and I get 36z squared minus 6z equals 90. This negative 6 is negative. First of all, I will have here 6z minus something squared. The negative 6 is negative twice a b. 6 and 6 cancel, half and half, negative and negative cancel. So twice b is 1, b is 1 half. When I square it, it becomes a quarter. And since I add a quarter here, I add a quarter there. So 4 times 9 is 36, and a 0 is 360, plus 1 is 361 over 4. I use my calculator, and I say this is 19 halves squared. Again, if it's confusing, stay with our method, but I believe if you get used to it, it's easier to make this a perfect square. So the left-hand side becomes 6z minus 1 half. The right-hand side is plus or minus 19 halves. So either, if I add 1 half to both sides, I get 6z equals 1 half plus or minus 19 halves equals 20 halves, or 6z equals negative 18 halves, right? 1 minus 19. I divide both, so this is 10, this is negative 9. Dividing by 6 and dividing by 6. I get z equals 5/3 or z equals negative 3 halves. And again, I can check and say if z is 5/3 and I'm gonna square it and multiply it by 6, then subtract it, I get 15, which is the right-hand side. And if it's negative 3 halves, meaning negative 1.5, oh, I'm sorry, negative 3 halves, which is negative 1/2, I'm gonna square it and multiply it by 6, then subtract it. I get 15. So I know it's correct. The second method tells you, no, divide the equation by 6, which is the same thing, but I will get z squared minus z over 6 equals 5/2, which is 15 over 6. Then I'm going to use the same method we did before. This is twice a, so I divide the coefficient, which is negative 1/6 by 2. It becomes, oh, I'm sorry, z minus 1 over 12 square. But by doing that, I have to add 1 over 444. Am I doing the math correctly? Yeah, I divide by. So I have to add 1 over 144, 1 over 144. So that becomes the perfect square. And the right-hand side, 5 over that. So I multiply 5 by 72, right? I will get 360 plus 1 over 144, which is 361 over 144, which is 19 over 12 squared. So when I take the square root, I get z minus 1 over 12 equals plus or minus 19 over 12. So I add 1 over 12 to both sides. I get either z equals 19 plus 1 is 20 over 12. Simplifying by 4 top and bottom, I get 5/3, which is the 5/3. Or z equals negative 19 plus 1 is negative 18 over 12. Dividing by 6 top and bottom, I get negative 3/2, which is the negative 3/2. Same answer, different methods. The last one has, in fact, number 9 would have been easy because the 4 is a perfect square, so you don't need to multiply by anything. But the last one, number 12, and I'm sorry it took long, but I wanted you to know both methods if the a coefficient, if the x squared coefficient is not 1. Okay, so doing it with the method suggested to you or the method you learn at school, we are going to divide everything by 3. So I get x squared minus 5/3 x minus 1 equals 0. Then I'm going to add 1 to both sides and get x squared minus 5/3 x equals 1. When I do that, I know that this is twice a. So if I divide it by 2, it becomes 5/6. So I know the left-hand side eventually would be x minus 5 over 6 squared. When I square that, I get 25 over 36. 25 over 36, which is 61 over 36, which can be written as square root of 61 over 6 quantity squared. I can write square root of 61 over 36, but I know the square root of 36 is 6. So I will get x minus 5 over 6 when I take the square root of both sides is plus or minus the square root of 61 over 6. I'm going to add 5 over 6 to both sides and get x equals 5 over 6 plus or minus square root of 61 over 6. So x is 5 plus square root of 61 over 6, or x equals 5 minus square root of 61 over 6. How do I check my answer? I will enter the 5 plus square root of 61 over 6. I'm going to square that and multiply it by 3, minus 5 times that, minus 3. And I get 0. Negative 1.7 times 10 to the negative 9. I go back and make that a negative instead of positive and repeat. So I'm going to square and multiply by 3, then subtract 5 times that, then subtract 3. And I get 7 times e to the negative 11, which is 0. So I know it's correct. Finally, the second method of solving this is to make that a perfect square. It's a 3, so the only way to do it is to multiply the whole equation by 3 and get 9x squared minus 15x minus 9 equals 0. So I can add 9 to begin with to both sides, and that will give me 9x squared minus 15x equals 9 plus something, right? What is this thing? The 15 or the negative 15 is negative 2 times, this would be 3x minus something squared, right? 3x. So 2 times 3, which is the a, times b. I can simplify 3 and 15, I make it 5, so b is 5 halves. 5 halves. But with 5 halves, meaning when I square it, it was 25 over 4. So I have to add 25 over 4 to both sides. 4 times 9 is 36, plus 25 is 61 again. So I get 61 over 4 squared. So I can write this as the square root of 61 over 2 quantity squared, which leads to the following. 3x minus 5 halves equals plus or minus square root of 61 over 2. I'm going to add 5 halves to both sides. And you can see now we are getting the same answer. It's 5 halves plus or minus the square root of 61 over 2, which can be written as 5 plus the square root of 61 over 2. Dividing by both sides by 3, I get x equals 5 plus or minus square root of 61 over 6. Right? 5 over 6 plus or minus square root of 61 over 6, and you get the rest is history. You get the same exact answer. I know it's a little complicated to complete the square sometimes, especially when the coefficient of a square is not 1, but you need to really practice this and feel comfortable that you can do it both ways. Or if you prefer, you stick to one way and use it, that's fine also. But I would rather have you learn both methods. So you can always, use one to solve, the other one to check. Or if one problem is easier one way or another, you can use that method. Or if your school, your teacher wants you to use a specific one, that at least you would know that how to do it. Um, Again, so now we learn how to solve the quadratic equation using factoring and using completing the square. Tomorrow, we are going to use a method that would work on any problem, because here we say maybe the factoring is easier here, maybe the completing the square is easier there. If you want a method that works every time, we will do that next session when we do the quadratic equation. We'll see how the quadratic equation comes, how you find it if you forgot it, because most people just memorize it. I hate memorization, but sometimes, again, we memorize, for example, the multiplication table, no big deal. But I want you to know how to derive it. So we'll go quickly over how to derive this equation, and then we can use it from now on without proof, of course. Okay, I wish you all the best. If you have any comments, please don't hesitate to let me know. I'll get back to you as soon as I can. And otherwise, I will see you next time. Have a great day.